All right, thank you for joining me. In this worksheet, we're going to look at what makes an equation of a line, okay? So we're going to get to this, and we're going to be writing linear equations in this one. This is worksheet 3-6 for the class Discovering Algebra 1, Part 1. All right, so in this video, we're writing our equation. It says to do it in slope-intercept form. Remember, we have two forms. This is the slope-intercept form, and just in case you were wondering, the standard form is ax plus by equals c. And there's more forms than that, but these are the only two. I mean, the others are more for nonlinear lines, in my opinion. All right, so m stands for our slope, and B stands for our y-intercept. And this is important when we're building these equations, that we understand what these two variables mean, okay, so that we can write these equations. We also want to see that our slope is the rate of change in our situation, and so that it's controlled by whatever x is, whereas the y-intercept is kind of a constant term that doesn't depend on a variable. All right, so these are pretty easy. We're just putting these into the equation form. So y equals mx plus b. 2 is my m. 9 is my b. Fill in my x and y because they're always varying. And my equation is y equals 2x plus 9. Again, in this one, got to put in my m and b. Everything else stays the same. My m is going to be 1 because that's the same as the slope. My 5 is going to be the b because that's the same as the y-intercept. Now this one's a little more interesting. My slope in this one is going to be a -3, and the -3 is going to be going to change that. We're going to have is going to give us a negative x term. So that's going to be a -3 right here, okay? So make sure you put that negative in. And then the 0 is going to go right where the b is. Now, it doesn't matter what x ends up being. If it's a 2 and that becomes a -6, if that's a billion and that becomes a -3 billion, either way around it, when I add 0 to it, doesn't change anything. So I can actually drop that 0 from the equation and make it y equals a -3x. Again, we're just putting our m and b in. We're just playing around with writing these equations. And our m is going to be negative again. And we have 1 for our slope. Now, adding a 1 is very important. Multiplying a 1, not so much. Like this number 2, I could have written it x plus 5. I didn't have to put that 1 in because 1 times anything is just x. X can be a billion. 1 times it is still a billion. Okay, but here, when I add 1, that is important. That has to stay in the equation. So this time it's y equals -7 plus 1. All right, in this one we have a fraction as our slope. Pretty exciting, eh? All right, so our slope is going to be 2/3. Got to put that fraction in. Our y-intercept is a 9. Now, if you write your equation like this, I ain't going to mark you wrong or anything, but I do want to point out that it's a little bit improper. We shouldn't have two signs. I can't add and subtract 9 at the same time. So our rules of integers, remember back when you were in pre-algebra, of the positive and the negative wins when they're different signs. Kind of like our rules of multiplication and division. So the proper way of writing that would be y equals 2/3x minus 9. And we see that same situation again in 6. We have to put our slope in, but this time we have that -6 again, so we need to clean up the signs and make it y equals 3/4 x minus 6. All right, let's take that whole thought of y-intercept, of slope y and y-intercept into these next problems. So I need to find my m and my b to be able to write my equation. All right, so y equals mx plus b, finding my m and my b. Well, I'm finding the rate of change and the constant thing that stands alone. M is not only slope, but you want to think slope, rate, anything changing. B is a constant. It's where I begin when I try to figure out the situation, and M is how I move throughout the situation. So in this first one, a car rental company charges a membership fee of $40 plus $10 an hour for renting a car. So it charges a membership fee of $40. No matter what, I'm paying 40 bucks. That's a constant. That's when I'm trying to figure out how much it's going to cost me for 10 hours of renting a car. I'm first going to say, well, I know right off the bat I'm paying $40. And then I'm going to pay $10 per hour after that. That's my rate. I have measurable units, so it makes it a rate. I'm measuring money to hours. Okay, so that's my rate. So that's going to be my M. Now I just kind of plug them in. I just kind of put them in that equation. Now I have to ask myself, also with the slope, is the slope increasing or decreasing? And this is your bill for renting a car, so of course it's going to increase. So it's positive. Some things to remember in these, okay, is what does X and Y mean? Well, X is going to be my hours. That's the hours of renting that I take advantage of. And Y is going to be my bill. It's the money. Ah, look at that. I'm comparing money to hours, the same as my rate. This is a really important concept to understand, that what your Y and your X should be should also reflect in your slope, because remember, the slope is my rising up the y-axis as I run across the x-axis. So it's made up of x and y values. So those units have to be represented in our formula, and they are. X is going to represent our hours, and y will represent our bill. So a cell phone plan charges $37.80 per month. The plan requires an activation fee of $25. So in the first month, if I'm trying to figure out that bill, I know that right off the bat I'm paying $25 no matter how many months. My plan is going to make me pay that $25. And I actually used to use a problem like this. This came from a bigger problem where we would compare pay-as-you-go phones to phone plans and all those little fees that you have to do with a plan versus a Go phone. And that's basically what this is getting at. How much is this phone really going to cost me over a certain amount of time? Well, I know it's going to cost me $25 for that activation fee, and then it matters how many months I have it. But I know it's going to be $37.80 per month. Okay, so now I need to drop these things into my equation. Oh, I'm writing the last equation. What's up? So my slope is going to be 37.8. I'm going to drop the 0 so it's not as, crowded in my equation. And the B is going to be 25. And I can even define my X and Y. That's not what the problem asked. The problem asked for this. At the top of the sheet says write the equation, but let's define it. X would be the amount of months that I have my service plan, and Y is my bill again. It's my money. Again, I'm showing the units that make up the rate that is the slope. Money per month, and it's being represented in my X and Y. You need an initial deposit of $50 to open a savings account. You deposit $150 each month in the account. All right, so I know to start it, I gotta have that $50, and for right now, I'm not taking anything out. I'm just putting stuff in. I'm just putting $150 each month. So money over months. All right. I'm going to drop everything into my formula. So my slope is 150. My Y is 50. That's what I started with, my initial, my flat fee, basically. And my X is going to be the amount of months that I'm actually saving instead of spending. And Y is going to be my money in my investment. All right. It looks like this is the last one. Yep. All right. The initial fee to have a website, and websites are no joke. They're all varying. Some of them have like a flat fee of like $100 and then no monthly cost, but some of them do have monthly costs. So if you want to have a website, and for this particular website, the initial fee to have a website using a server. So we're talking about a bigger idea here. Not only am I getting a website, I'm getting a private server for it. It's $48. It costs $44 per month to maintain it. So somebody's making some money. Actually, I don't think that's very good money for the market for that particular field, but we'll see. We know we're going to pay a setup fee of $48. That's our flat. That's our just one time gonna pay it, does not depend on the amount of months. But the 44 is my rate. It's my money per month. So that makes it a rate. All right. And we can just drop that into the formula that is the website, our equation, sorry. And our 44 will be our slope and our 48 will be our y-intercept. All right, and we can define a few things. X is going to be the amount of months that we have the service. And again, I use the same exact problem to when we do systems of equations in part 2, we actually do this problem again to see when we need to hire someone in-house to take over what this maintenance team is charging us each month. When does it become beneficial? Like, do we have 2 years before it's costing us money, this decision? Do we have 4 years? Do we have 5 years? How long can we keep this service before we need to hire someone, get someone trained and in there to do it for us in-house? And why is going to be our money? And that's something businesses have to consider. All right, but this is what it asked you to do. All right, I'll see you guys in class. And when we come back, I believe we're on parallel and perpendicular. Yeah. So up next, parallel and perpendicular.